A lot of guys, you guys already met me. I graduated in 2013. Actually, I graduated in 2012 December, so I'm class of 13. So yeah, it's when we were here, we were only like recruiting 6 master's students every year. So really, I was expecting that this is really just a the way we did career session before is that we pretty much squeeze in the small meeting room in the 7th floor and have pizza together and talk and ask questions. But when I see Beth send the invitations and said the location is 245, I was like, really? Do we need that big a room? Yeah, I didn't realize that we're growing that big right now. I heard from Zihao that we are already recruiting 18 students this year.
We have 15 for next year.
Oh, 15. Okay.
Yeah.
Cool. Yeah.
So that's our goal, is 15 a year at this point.
Great. That's more than twice of what we were. Yeah, very impressive. And so you want to be a data scientist? Yes? No? Well, I guess we'll find out after the talk.
We want to make a lot of money.
Well, yeah, we'll find out. So this is, I pulled this picture from Google Trends to show you where this industry gets growing. It's pretty much at the time I graduated in 2012 and 2013. So when I was at school, I totally haven't heard of the word data science. And yeah, so you guys are already ahead of me right now, planning for a career in data science. I wish I did some preparation when I was at school, taking advantage of the classes, but I didn't. Yeah, so it pretty much, big data grew a lot exponentially after 2013, and so is data science and data scientists. Well, probably not as fast as biostatistics and Brown growth, but still very impressive. Hopefully this industry goes faster than us so that we can all get a good opportunity for employment. But anyways, so what is big data? I try not to put too many definitions in my talk because I'm just at the starting of my career, and this industry is very young as well. It's one of the very lack of definition industries. So, but still, I think it's like I said, if you ask 5 data scientists, you'll probably get 6 opinions. So, but I think it's very helpful to tell you the different kinds of big data and different industries, how do they use big data, so that you can get an idea of what kind of jobs you guys are going to target, and what are the difference of the different job description means. It means they use their data differently. Usually what we see from a very typical statistical related data scientist job description is that you are using the customer's data to make better prediction of their click-through, their revenue, and their market. So these type of business analytics data science are basically dealing with their customer database and try to optimize their customers' experience by either better targeting or target the customer and serve them the right product. So it's basically answering a who and what question. Who is who to target in your database, and what is what to recommend to your customer. For example, Yelp can show you an ad. It can first answer the question who to show the ad to. Maybe if they see you turning off Yelp app every time whenever you see an ad, they might decide not to show you. When you click on an ad, they might show you 2 ads next time. Similar to Pandora, whenever they show you an ad, they risk the chance to lose you. So they first have to answer the question of whether are you the person that is going to make the money at all. And then once they determine that, they have a small fraction of customers that they are going to target, they are going to answer the question of what are they going to show you. When you search for a Chinese restaurant in Yelp, they might show you a related ad of a similar Chinese restaurant or Japanese restaurant, but probably not an Italian restaurant because they, from their previous customers' behavior, they figured out that Chinese restaurant and Italian restaurant are totally different two clusters. So these are typical questions business analytics do. And the next one is the IT industry. So they are more interested in AI. So basically, they are trying to use the data, more of data in terms of information rather than data as a number. So the information they collect is more from different sources, like image, like speech, or sometimes from text, as they do a lot of natural language processing. And for example, in our company job case, the engineering team also do search engine optimization. They go through the job descriptions from the job post and try to find out the job descriptions most related to your search. So that's a lot of natural language processing. It's more IT related, more computer science, engineering than statistical modeling. Also, it's the finance industry use it as well. I guess Mengqi will probably walk you through this industry because I have no experience in finance. I'll leave this to Mengqi and probably some other industry. So a question I was always asked from a statistical background student is what is the difference of statistics and data science? Actually, I was just asked this question from Dr. Luo half an hour ago. So this is the answer. Statistics is more interested in doing inference from a small sample and try to infer the population by the sample you collect. And a typical traditional way of doing marketing research is basically just send out the surveys and collect the surveys and try to infer what kind of users are more likely to be interested in your product. But right now, when you have big data, you don't do the inference from your survey. So they pretty much have a customer database. When they are doing surveys, they are more interested in standard error, p-value, same thing, and survival longitudinal, similar. They are basically in the trying to guess the population from the sample. And also, I forgot to write here, bias is also a statistical term. When you are switching to big data, we don't quite care about bias because we're not making inference. I'll elaborate bias a little bit later, but usually we don't adjust the bias and we don't do imputation for missing data. Missing is just a missing. And yeah, but what statistics share with data science is basically we both predict y hat by likelihood, and there's data mining, basically finding the valuable correlations in statistics as well, and also in data science. And visualization, similar thing. Visualization is actually part of data mining, and some Bayesian analysis. But data science also focuses on predictive modeling. Actually, predictive modeling should include y hat, but I put it here because the predictive modeling in data science is bigger, includes more types of models than statistics probably. And the reason there's more models, for example, random forest, gradient boosting, those models are very hard to do interpretation. Like linear model, is a very easy to interpret model, but if you're using a lot of assembling models in predictive modeling, it can't interpret it. You can't say that, okay, by increasing this much of x, I'm going to expect that much of increasing y. You can't interpret it this way. All we care is probably just a prediction, the cross-validation score. And also, you need business domain knowledge because data science is basically trying to answer the practical questions in a business setting. So you got to transfer your models in a language that can help to improve the business. So you need some business domain knowledge to know where does your data comes from and what kind of association might the feature have. These are some these varies by business industry, and the specific industry's domain knowledge is very important for feature engineering. Hacking skill, I guess Mengqi will walk you through how they use Spark and Hadoop to optimize the prediction. We pretty much use H2O, and H2O is very easy to use, to implement. So, and also some big data skills. These two are pretty much same thing. A lot of people are describing data science using this picture. I'm sure you guys are familiar with this picture because it's pretty much everywhere. However, if you're wanting to be a data scientist, you don't have to have equal skill in each of the domains. What I imagine data scientist is pretty much like you have to be very good at math and statistics for sure, and you have to have reasonable knowledge of hacking skills and business domain knowledge. You have to have business domain knowledge to convert your findings to translate it into a language that the business team can understand. And you also have to have the hacking skills to implement the model, to train your model in a large scale. And but you don't have to be as good as hacking as a data engineer, because their goal is usually data engineers and data scientists work together to help the data from collecting to train and then to implement to production. So because you just can't find a candidate that's equally good at hacking and math, so these two kinds of roles are usually working together. And there's another role that always works with data scientists. You probably can't see it here. I put data analysts here. So data analysts have a lot of overlap with data scientists in analytical skills. They pretty much have all the analytical skills as a data scientist, but they do less modeling than data scientists, and they are more of using their analytical skills to make A/B tests, to do correlation association tests, and find out basically something interpretable. And but they are spending less time training the model and implementing the model. So what does data scientists do specifically? Basically, if I want to summarize it in one sentence, that will be to leverage the data to make decisions. So it includes all kinds of skills from collecting the data to making the prediction, and basically use the data to inform you to do something, make a conclusion. And it starts from data wrangling and data munging. Basically, you have to have these big data skills to get the data. That's the first step of doing everything. You have to have the ETL skills. Usually when you're at school, you're more likely to just get the data from a CSV file, but the CSV file never exists in big data. So you get to either query the database or query an API that gives you the data. And sometimes you have to collect the data by yourself. So you need to have some web scripting skills with Python, for example. And I put feature engineering here, but feature engineering is really probably more modeling skills and exploratory data analysis. A lot of times our questions are very open-ended, and you have to ask yourself, what can you get from the data? If you just stare at the data and don't ask the question, you will never find anything valuable in the data. So, so basically, to me, exploratory analysis is trying to take useful information from your data and try to find a association or something valuable you can interpret. And then that's the most important step, prediction modeling. There is classification, regression. This is more of in the domain of statistical predictive modeling. But there are other skills like natural language processing, recommender system, information retrieval neural network. These are more of in the computer science domain. But to be a data scientist, you should be able to master all of those. Maybe not getting super good at all of them, but at least the classification and regression, you have to have enough skills to use different predictive modeling to optimize your cross-validation score. And also, sometimes you have to prototype your data products by yourself. So you have to have some scripting language. So this is more of in the data engineer's domain. And also machine learning. Well, sometimes they call data engineer as a machine learning engineer. So they are usually working with data scientists. And also data mining. A lot of times, what you think is you can make a perfect model and that pretty much is all your job. But actually, in real time, data mining and finding the important association can inform you a lot by to create better features. And just by looking at the two by two table can probably help you to find out a very important pattern in your data. So so you should be very good at data mining and sometimes data visualization, a part of data mining. So I was asked about the question whether breadth or the depth of the knowledge is more important. If the audience is pretty much undergrads, I would probably say the depth is more important. You need to dig into the algorithms. But since you guys are graduate students, I believe that you have enough statistical knowledge to understand each of different type of modeling. But breadth is very important because you are probably more of better in statistical skills than all other skills. And what we are looking in the industry is pretty much following the what you call barrel principle, meaning that the lowest bar in the barrel pretty much depends the capacity of the barrel. So we don't look for someone who are very good at one thing and below average in the rest of the bars. So we're more looking at someone well-rounded in all kinds of skills. You don't have to be super good at them, but you have to at least have the knowledge at them, because we believe that by training or by working experience, you can improve all your skills. So at the beginning level, we don't expect you to be an expert in terms of depth. We hope you to be well-rounded in terms of the breadth of the knowledge. And also beyond the technical skills, we are also looking for some analytical mind. I'm sure all of you guys are because you guys already have math background, so you should be able to be fairly good at analytical problem. But a lot of times you have to define the problem. This is something I don't get from the training, because what I get in school is pretty much a defined problem. It's pretty much like I learned the knowledge and I pretty much learn it to take the exam, and the exam is the question asked by the professor. I don't ask myself the question, but the professor does. But in real life, a lot of times no one asks you the question, but you have to ask the question. So you should be able to define your question and ask the right question. And a lot of times what you find from a fresh graduate is that they tend to get distracted by the fancy ideas, but don't ask the right question because either because the size of the impact of their question, and also because the false pre-assumption for the question they asked. If, for example, the click-through rate is usually a very, very little rate in a very highly skilled industry. It's probably like, for example, 1%. If you find that, oh, I find that people who clicked are more likely to click again. Yeah, sure. They probably will have 2% click-through rate. And then you conclude, so next time we should set up a campaign to target these previous clickers. But think about the size. It's just a 1% of your users. If you add these people in, those are just probably improving your click-through rate from 1% to 1.02%. And that's 2% increase. Okay. If it doesn't spend too much of your time to set up the campaign, that's fine. But a lot of times, the trade-off of the time you spend on it doesn't make up the cost. So that's why I say analytical mind is very important. And also, data-driven minds, pretty much the same thing. You gotta use your data to back up your ideas. And why? Because when you're communicating with either the business leader or your group member, you got to support yourself with some data, because data is your best weapon. And if you don't know how to well, you probably should have enough skills to grab the data to support yourself. But communication is very important as well. You got to communicate effectively to the leaders. Otherwise, you lose your audience before it gets to your conclusion. And also, you need to inquisitive, curious. This is especially important in the big data industry. The skill sets we request is changing all the time because there's new techniques coming up every year. You gotta be able to ask your question, what do you need, and also look at the question from different angles and ask yourself, can you do this? Can you do that? And problem solver, we are, especially when you are working in a smaller company or a startup, we're pretty much we work in a group, but our role are all different. If you have a problem, just describe the problem to your teammates will probably take half an hour, and it'll probably take them another half an hour to solve it for you. And a lot of times they don't have any more experience than you do. So a lot of time you got to work on your problem by yourself. And also you need to be a fast learner and lifetime learner, especially for big data skills. So I also want to say more about how is it working in a startup, because working in a startup is totally different from working in a big company. I spent 2 years working in a bigger organization, and then I switched to a startup. At the first time, I was pretty impressed by the environment of the startup, but I like it, but it's very different. I think it's important to let you guys know what you can expect in different kinds of organizations, and from there you can choose your career path. In a startup, we are working very, we experiment and pivot our ideas all the time. A lot of times you find that you work on something, and next day you find out that there are something else more important to work on. So because a startup is basically a big experiment, And in this experiment, we carry out a ton of small experiments. And we're hoping that some small experiment can succeed, and that determines how our business can succeed. So we're working in a very fast pace, and we are also looking for the candidates that can drive themselves. And if you are a person who wants to achieve significance, then startup is definitely the best place for you. It recognizes the contribution for anyone, even if you're a team, even if you're not a team lead, you can still contribute a lot to the company. But you are not directed by anyone. So pretty much every day we define our job duty by ourselves, and we decide what we want to do. And the good thing is that you're never told by to do anything. You choose the interesting problem and solve it. And the bad thing is that when you still can't finish at 5 p.m., do you want to go home, or do you want to stay there and finish the thing you wanted to do? Yes, you are doing the thing you wanted to every day, but you're not guaranteed that you can finish before that, just because a lot of times when you wanted to do something, you don't have the experience to tell you, or no one have the experience to tell you that this thing is going to work or not. So a lot of times you're just finding that, oh, I need to figure out how this works, how that's work, and Googling it, and finally get the code done and realize that, oh, it's already 10 p.m. So when I just started my job, I was working crazy hours, and a lot of times I was picking up SQL, but one of my friends is asking, so what about the lifestyle, well, what about work-life balance in your new job? I was like, if you care about work-life balance, that means you're probably not quite a startup personality. Startup is great for those who are self-driven, but it's not for everybody. So yeah, what we do in job case is basically finding the CTR, basically answering the question of who to target, who is more likely to click our job recommendation, who is more likely to click on our app, or who is more likely to unsubscribe. So we want to avoid those unsubscribe events and try to make the max from a user. And we also want to optimize the user's experience, because once we do that, the user are less likely to churn, to go away. So we sometimes do recommender system to match the job based on the user's previous click behavior. And we also have to scale the call center volume, because we don't want the call center volume to go up all of a sudden and go down all of a sudden. Because when the volume go up, we find out that there's not enough representative to answer the call. When they go down, there's too many representatives just waiting for the call. So these are very practical questions, and you got to use prediction modeling to predict how many clicks are you going to have, how many call-in are you going to have in a particular hour of the day of the week, and also some engineering team are working on the search engine optimization by information retrieval. We have a lot of interesting questions to answer. We actually have more questions to answer than we have the people to answer them. So a lot of times we're quickly triaging our questions and try to answer the most interesting questions, or the questions that can give us the most significant results. It's very interesting experience, and I am enjoying it so far a lot. And a quick walkthrough of my background. I worked in the Jackson Foundation for 2 years after I graduated, and I was working as a biostatistician doing typical biostatistical job. And I worked there for 2 years. That's the time big data started to grow, and I started to I learned big data actually from Coursera when I was taking some epidemiology or statistical courses, and I learned the machine learning course from Coursera, and then I realized I probably need to dig more into it, and I trained myself with some MIT OpenCourseWare courses or Stanford Classroom courses from YouTube, actually. Actually, I found YouTube is better than Coursera in terms that it gives you more depth of the knowledge, and sometimes the class notes is very helpful than a book or a class. So I then moved to job case after 2 years working in Henry M. Jackson Foundation and work until right now. During when I forgot to mention that when I was in Henry M. Jackson Foundation doing statistical jobs, the reason I switched to big data is because I saw a lot of my coworkers with similar background, master in biostatistics, they are seeking for to get into a PhD program. So I can see a career ceiling very soon. So I was spending a lot of time asking myself, what should I do next? So I asked myself the most important questions. I'm sure a lot of you guys have asked yourself. That is, should I do a PhD, to PhD or not to PhD? So so I spent probably half a year asking this question, and at the same time, I keep on training myself in Coursera, and it's because I pretty much took all the data-related courses in Coursera, and finally ended up in the machine learning course started by the founder of Coursera, and I dig more into it from his YouTube version of the classroom version of the course, and started to get interested in this field. But there is a big gap between statistics and data science. So this is how I prepared. The round one took probably 3 months. I did some machine learning training from YouTube, and also from other open source MOOC. I don't remember how many courses I took, but I try to pretty much Google it from YouTube when I have a question, something like a natural language processing or information retrieval questions. If I don't understand it, I'll just try to Google it from YouTube. And then I took Intro to Data Science course from Coursera. This is a very good course at that time, but right now there's a lot of better courses. And I also took Cloudera, its certificate at that time, but this is not available at all. I'm talking like I'm from the 1990s, but actually this is just what happened last year. Yeah, a lot of them. I try to recommend this Coursera course reading list because there are 10 books. I quickly go through all of them. I didn't go into the detail, but those 10 books are very helpful, but it's not there anymore, unfortunately. They probably updated it with 2 different certificate, and probably with emphasis in data science and another one in data engineering. But anyway, I took all of these within 3 months probably, and then I started to submit my resume. The first round of submitting is not quite successful because I got some interview and I failed 3 on-site interviews for the same reason. My coding is not that good, and I failed them pretty much in the same questions, similar type of questions, and they're all whiteboard questions. They're expecting you to be a junior level engineer. So I then went back home and took more courses in data structure and algorithm. So these are the basics for the whiteboard questions. And also cracking the code 150 is very helpful. It's written in Java, but the questions is very similar to what I was asked. And this is actually more junior level of algorithm question. And then I move on to lead code, which is a higher level of computer science problems. And I didn't took all the 200 lead code questions, but I took around 20 of them. And pretty much what I was asked is pretty much just on recursion, permutation, pretty much like finding a change of a coin. That's probably the only, or n-sum, 3-sum, 2-sum questions. Yeah, that's all I can remember at that time. It's interesting that I failed all the round one submission, resume submission by the same reason, but eventually I got a job in job case, which doesn't ask me these kind of programming languages. I guess what I want to say is that there are different type of roles of data science. When you submit your resume, you got to be sure what kind of role it is. Is it more of statistics or more of engineering? I guess Mengqi will probably walk you through from another angle, from the engineering angle, that for the data science. So so that you guys can get a grasp of data science in two different kinds of views. There are other very helpful resources I want to mention. Other than that, Kaggle, I mentioned it multiple times. It's very, very helpful, especially for the type of role I was in. I found that pretty much every single questions in Kaggle can be translated into a similar question in our company. And you can see that we're predicting CTR, we're predicting, recommending the right product to the customer. You can tell from the title of these computation. And we're also optimizing the search engine by natural language processing and recommend the right job to the user. So all of these Kaggle questions pretty much answers what we are doing in job case. So if you want to have some knowledge of what the industry is doing, how they are using the big data, you can go to Kaggle. The only difference is that Kaggle is using a small fraction of their data because they A, they don't want to release their whole database. B, they want to fit into a memory so that they can have the most people to sign up for Kaggle. But the model we use are very, very similar in the feature engineering techniques. And on top of that, I want to mention some books. Elements and Introduction to Statistical Learning. These are the classical textbooks. I'm sure all of you guys have heard of it. Cracking the Code Interview and Lead Code, I've mentioned before. These are from the engineering side. And these are the books I can think of, but there might be other books. I don't remember it on top of my head. And Quora, if you want to answer a question of what does this industry do, how should I get prepared, these questions are pretty much in Quora how-to section. So so basically just a search for how do I become a data scientist, how to become a data scientist, what should I learn to become a data scientist. There's very good resources from different from the experts of different industries. So they can give you a more a better view than the review of myself from my limited experience. And also, as I mentioned, YouTube, MIT OpenCourseWare, and Stanford's recorded classroom course are very helpful. I generally prefer YouTube than any of the MOOC course because I think YouTube classroom version give you a more depth of the training. And Kaggle, actually a lot of you guys mentioned that if you want to register a course, for example, machine learning, but it's not available for this semester, I guess we don't. When you're in a job interview, you're not going to be asked about did you take this course in Brown or did you take this course in from somewhere else. All they care is whether you have the knowledge or not. If it's not available this semester, you can just take it on YouTube or anywhere. As long as you have the knowledge, that's enough. You don't have to have that show up on your transcript. Kaggle, as I mentioned, you can learn predictive modeling skill and work on real industry problem. And sometimes you can get a buzzword on your resume. Basically, like when we are screening resume, we look for, do you have experience predicting CTR? If you put CTR there, they might just, it might bring up a conversation between you and your hiring manager of how you did it. Otherwise, you don't even have a topic that you can talk about during your interview. Some other MOOC courses. So these are some GitHub links, but these links include like tens and thousands of resources. So it's not one MOOC course, but it's a compiled list of the courses you can take and keep on training yourself. So yeah, that's pretty much of my talk. Is data science the right career for you? You probably will answer it by yourself, because this is your own question, and only yourself know where your passion is and where how do you like it. So at least it worked for me. I switched my career from traditional statistics to data science, and I am still in the honeymoon period of with data science, and I think there's still a lot to learn for myself. This is somewhere that requires a lot of learning. So if you ever decided to do it, that's pretty much like you are keeping on learning new skills throughout your life. There's not a time that you can stop and chill and enjoy a perfect work-life balance. I can probably envision it right before I retire, but not in the near future. So what I ask from you guys is very important to share your failure interview experience with your classmates. You don't have to share your successful experience because what they are looking for is what's most beneficial to them is not to make the same mistake as you do. A lot of times for data science, you guys are not trained for data science. It's very common that you fail in a coding interview. So share it with your classmates so that your classmates wouldn't fall in the same place as you do. It's very important. I got a lot of very helpful input from the previous alumni from Brown, and I'm still very grateful, and we're very good friends right now. So please don't be too shy to share your failure experience, and because I'm sure that you will share your successful interview experience, but failure experience is also important. And don't be too shy to reach out for advice. Here's my email address. You can email me anytime you want. We can schedule a time to talk, and we can. We're not hiring in job case right now in our team. We are more looking for the data scientist with an engineering background. But I can still give you some career advice and where are you, what's your weakest point, and go through a resume. How do you structure it in a more data science way? And also, when you graduate and find a job, don't be hiding your own job. Still keep in touch with the program and helping other students. And because right now we have a community of biostatistics. When I was graduating, I can't find anyone. I was talking to Chris. I don't know if you remember at that time. I was like, I can't find any alumni. We don't have any alumni in the industry. So I was reaching you out for industry, and you actually gave me some feedback from a recruiter in Hudson, or I forgot. But basically, what they're saying is just that they're not looking for fresh graduates, and yeah, it's very important to get the advice from someone who is already in the industry and tell you where you are falling short of, and get prepared before you graduate. And never stop learning, no matter whether you're in the big data industry or not in the big data industry. Learning is probably the only way that can help you to succeed in a technical field. So yeah, that's pretty much of my talk. Thank you.